This is a video for the test review day warm-up for our pre-calculus vectors unit. So the first problem, given vector u is negative 5i plus 7j, and vector v is 6i plus 7j, find u dot v. Okay, so first I would rather have my vectors in bracket form. So the I is the x component, the j is the y component, and then this dot is not multiply, that means dot product. So u dot product v, that formula is on your formula sheet, is we're going to multiply the x values and add that to multiply the y values. We get 19. And find the angle between the vectors. We need the dot product in that formula. So that formula is cosine inverse u dot product v over the magnitude of u times the magnitude of v. So I have the dot product, but now I need the magnitudes. So the magnitude of u, square the x, square the y, add them together. Same thing for v, square the x, square the y, add them together. And now we're going to type this in your calculator. And you should get 76.14 degrees. So make sure that you're in degree mode, and when you type that in, this is the solution you get. Okay, number 2. Perform the vector operations with the diagram. Got some colors here. Oh, but first, AD minus CD. So minus means opposite direction. So instead of minus CD, I'm going to think of this as adding the reverse, which is D to C. So if I go vector A to D, there, and then D to C, these line up head to tail. So I have the end here and the beginning here. So the shortcut pathway would be to start at A and end at C. So the answer is vector AC. Now for B, this one's adding. So I've got AD plus AB. And when the vectors line up starting at the same position, I can't add them the way they are. So I have to translate one of them. I'm just going to translate this one because that's the same thing as BC. So now this is the start. Then we can continue here. So the result is starting at A, end at C. If you want, you could even say that this is 2 of the vector AE, which is that part of the diagonal, or you could say that's 2 ECs from E to C. I just think this one's easiest. It's the whole pathway. All right, part C, we've got another subtraction. So I'm going to add the reverse. So we've got A to C, C to B. So the final result is A to B. Starting here, the shortcut pathway would have been to go the vector AB. All right, last one. AB plus DA. So now that I've drawn the vectors on my diagram, I'm going to ignore the order that the addition problem is written in. Because it doesn't matter if it's AB plus DA. This could have been typed DA plus AB. So when I look at my pathway, I see this is the start, B is the end. So our result is the vector DB. Okay, on the back. A word problem. We're going to make a diagram to help. Take a minute and read the question. A plane flies due north. Okay, so make a plane diagram. Due north is this direction with an angle of 90 degrees. And then the wind is blowing east. That's a direction of 0 degrees at 30 kilometers per hour. Find the velocity after 1 hour. So if it's 100 kilometers per hour, this vector has a length of 100 kilometers, and this vector has a length of 30 kilometers. So the resultant vector would be if I add them together. So 100 cosine 90, 100 sine 90 for the plane. I'm going to add that to the wind, 30 cosine 0, 30 sine 0. You can type them in your calculator, and you should get the vector 30, 100. Which kind of makes sense because this vector is over 30 up 0. This vector is over 0 up 100. So 30 plus 0, 100 plus 0, it works. All right, find the magnitude. Type that in your calculator and rounding to 3 decimals. And the units are kilometers. Okay, the direction. Well, first, let me figure out what quadrant this is in to see if I'm going to have to use my answer as a reference angle. So 30, 100. So in quadrant 1, the value of this tangent inverse is the answer of the direction, because here's our theta. So when you type that in your calculator, you should get 73.301 degrees. All right, let's try the last one on page 35. We've got another airplane flying west for 400 kilometers. And then, then it's going to change directions to 20 degrees south of the west. So here's the west, 20 degrees south of there for another 1,000 kilometers. Okay, label the plane's direction as angles in standard position. So for the original, the starting, this angle is 180 degrees. And for this one, here's our angle direction. So we're going to go 180 plus 20, and that would be 200 degrees. All right, find the resultant vector. So we've got 400 cosine 180, 400 sine 180. We're going to add that to 1,000 cosine 200, 1,000 sine 200. Negative 1,339.693 and negative 342.020. Okay, distance, that means magnitude. So in your calculator, we've got the square root of the x value squared plus the y value squared. When you are squaring a negative in your calculator, you need these parentheses. So make sure you type the whole thing like that, and we get 1,382.662 kilometers. All right, so this vector is negative, negative. So that's a quadrant 3 vector. So our direction is going to be 180 plus whatever the calculator tells me. So let's do tangent inverse y divided by x. And that gives you 14.322 degrees. So we're going to add that to 180 because this is the 14 right here as a reference angle. So our final direction would be 194.322 degrees.